Welcome to this session all about fuel pump modules. We're going to be taking you through three key areas. We're going to look at the fuel system and where the module fits in. We're going to look at a little bit more detail around the fuel pump module, how does it operate and how does it work. And then finally we're going to take you through a real basic test of how a technician would diagnose and identify a faulty fuel pump module. So the fuel pump module is probably one of the things that is the most forgotten about, but is absolutely essential to the key running of either your petrol engine or your diesel engine. So if we look in detail a little bit at the fuel system components, we always start off with the tank and the fuel pump module. Sits inside the tank and can be accessed from either the top, or on some vehicles the fuel tank has to be removed and then it can be, the fuel system module can be removed from that tank then. After the fuel pump module, we then got the fuel pipes, and the fuel pipes carry the fuel through to the engine all the way onto the fuel rail. Now, depending on the system, there may or may not be a filter in line. When we get to the fuel rail, the fuel is then delivered from the fuel rail, it is shared to the injectors, and the injectors spray fuel into the cylinder. And that keeps everything running perfectly. So there are two different types of systems. We have Mpi and Gdi. Mpi is for multi-point injection, Gdi is for gasoline direct injection, and petrol engines fall into one of those two categories. For diesel, we generally have Di, which is direct injection, or we have CRI, which is common rail injection. So those systems, but all of them require a fuel pump module. Now, on the rail itself, the rail can be made of either plastic or metal. Traditionally, earlier systems were all made of plastic. The later systems metal, but all GDI injector rails are metal. Now let's look at a Mpi system, that multi-point injection. This system can be one of two designs. The first is a return system. So the fuel leaves the fuel pump module, travels down the fuel pipes to the engine, where it sits on the rail. At the end of the rail, there is a small pressure regulator that maintains just the right pressure in the system, and any fuel that's not needed is then returned to the fuel tank. So here, the fuel pump pressure regulator, the bit that makes sure the pressure is just right, it sits at the end of the rail. Later systems, they move the pressure regulator onto the fuel pump itself, or just as it leaves the fuel tank. So these systems were returnless. They had one pipe that went from the fuel pump module all the way up to the rail, and there wasn't a return. So let's have a look at the fuel pump module in a little bit more detail. So the fuel pump module is made up of two sections. We generally have the pumping part, which delivers the fuel to the engine, and the sender part, which delivers the information about how much fuel is in the tank to the driver via the instrument panel. Now, the pumping module itself can be looked at in one of two ways. It delivers both pressure as a first stage, and second, it delivers flow. Now, as a rough guide, the pressure from these pumps can range from anything from 0.5 bar all the way through to around about 8 bar. And in terms of flow, they vary again depending on engine size and engine power outputs, and they vary from anywhere between 70 litres an hour all the way through up to 200 litres an hour. We're going to come back and look at the fuel pump in a little bit more detail, but for now let's just quickly look at the sender unit. The sender unit consists of a metal arm with a plastic float, and as the fuel level rises, the float lifts up, and the arm is connected to a variable resistor inside the module. As this resistance changes, this signal gets transferred to the instrument panel, and that displays the correct level of fuel which is relevant to what's inside the fuel tank. Now, looking at the fuel pump module itself, the pumping elements, it can be powered in one of a few ways. The first way is the more rudimentary way. That is, the power is taken from the battery and is sent via a relay or a control of some sort, and it is set directly to the pump. When the engine's running, the pump's running. When the engine goes off, the pump shuts down. So this setup has been as it is for quite a while, but then we realised that we don't necessarily need the fuel pump running at full power the entire time. For example, if the engine is simply idle or light load, then we don't need the full pressure and flow that the fuel pump can deliver. So in order to be more efficient and reduce emissions, it was discovered that if we reduce the power to the fuel pump during certain conditions, say while the engine is at idle, then we can reduce the electrical load on the engine, and as anything, if we have to produce less electricity, then we don't have to burn as much fuel. So the two systems are, we either have direct power to the pump and it runs all the time, or we have a variable power to the pump. Now to do this, a controller or an ECU is required, and it just sends a signal to the pump and it can turn the pump's output up or down depending on the driver's demand. So we've had a brief overview of the fuel system and we've looked at some of the components. We've looked at the fuel pump module and the sender in a little bit more detail. But now I want to move on to how the system would be tested by a technician to identify a potentially faulty pump module. Now, the technician can perform one of a few tests. The first one and the most easy one to do is a basic pressure test. So the first step is we connect our pressure tool and pressure gauge to that vehicle. Delphi Technologies pressure gauge operates from -1 bar to +35. And we connect it to usually where the fuel filter or the fuel rail is, and we can carry out a basic test. Now it's important to note that at this point the technician isn't sure whether this is direct power from the battery or this is fed by the computer, which is controlling the pressure. So to avoid any incorrect readings, the best practice is to plug in your Delphi Technologies diagnostic tool and run a special routine that operates the pressure of the pump at maximum. So that doesn't matter then if it's controlled by an ECU or it's directly powered. By running the diagnostic routine, you will always get the same results. The pump will operate at its normal maximum pressure. That way the technician can perform the pressure test, get the result, and he knows that the result is a valid one and isn't the reduced value, isn't that of because the ECU is turning the pressure of the pump because the engines are idle, for example. So once the technician has confirmed that the pressure seems okay, they can easily then carry out a flow test. So this fuel flow test consists of putting the fuel pipe into an open graduate, running that diagnostic routine, and seeing how much fuel flows out over a given time period. It's quite common to use something like 30 seconds or even 1 minute, and then you take that data and you compare it to technical data. Now, most technical data in this will give a flow value of around, it'll be in litres per hour. So all the technician has to do is, if they run it for 1 minute, is multiply it by 60, and that gives them litres per hour. And by comparing that to technical data, they'll be able to see whether the fuel pump is delivering fuel in spec or it is out of spec and further diagnosis or replacement is required. So if that technician does find that the pressure or flow is incorrect, then the best next step is to go all the way back to the fuel pump in the tank, where it may or may not be easy to access. They connect the same equipment onto the fuel pump directly and they run the same test again. If they find that the pressure is much better at the fuel pump but not so good at the engine, then that indicates a potential blockage in the pipe. If the pressure is good at the fuel pump, then it looks like we're good to go. So if the fuel pump or the fuel lines aren't particularly accessible, then the technician may choose to carry out an electrical test. Using an oscilloscope from their toolbox, they can actually test the amount of electricity flowing around the pump. If there is too much electricity flowing around the pump, then that suggests the pump is working too hard and there may be a blockage. If there is not enough electricity, then that could suggest either a faulty pump or there is a fuel leak and the fuel is flowing too freely. So I hope you found this introduction to fuel pumps a great insight, and be sure to check out our other videos.